Good morning, everyone, and good evening to people joining from the Eastern Hemisphere. Welcome to Ati Motors webinar series. I am Siddharth Bhagra, leading global sales at Ati Motors. The idea of starting this webinar series is to decimate the knowledge that Ati Motors has developed over the last several years. As large marketing, manufacturing industries, typically automotive, uh, is an area where we work very deeply in, is fast embracing the Industry 4.0 automation. Automating material movement inside their facilities is an inevitable component nowadays for process flow. So Ati Motors was the first one to introduce AMRs with 3D LiDARs and natural navigation, which are ISO certified, autonomy safety certified. Ati Motors has proved that affordable automation solutions using its Sherpa brand of AMRs is indeed possible for large-scale implementation at multiple customer sites. The topic today for our discussion is understanding VDA 5050 from an Ati Motors perspective. Please use Q&A window to pose your questions. We would try to take as many questions as possible, with especially trying to group them together to cover a certain topic. I want to introduce our speaker today, Mr. Guru Prasad. He's an industry veteran with career spanning decades in telecom, IT, cloud computing, and robotics. At Ati Motors, he's been there since inception, and today is the head of our deployments globally. Without further ado, please welcome Guru Prasad.
Thank you, Siddharth. Thank you, Siddharth, and good morning, everybody. Good afternoon and good evening. So yes, this topic is it's very interesting from Ati's point of view as well. Over the last several years, 5, 7 years now, we've been deploying bots in customer locations around the world, in India, in Southeast Asia, as well as the US, North American geography. What you see in the foreground in this picture is a fleet of vehicles built by Ati Motors, each one built with a specific use case in mind. Now, to motivate today's topic, let me give you an example. Typically, what we see out in the shop floor of manufacturing facilities. So generally, the lines require raw material. These are delivered from racks. So these are all small parts which you put in a tugger, put in a dolly, and the tugging application is the one that comes to mind here. The tugger, a series of tuggers that we have, would then pull the carts or dollies, as you would call it, to the production line. And when part of the process is done, either you have a semi-finished good or a finished good, which you would then walk it through a QA process, for instance. Now, the part is not really small, so you would perhaps transition from a tugger to a lifter because it's nearly complete. So there you have a case of using a second automation vehicle in this process. And then when the QA process is done, or a certification or a testing process is done, you would then put that in a carton, which probably is palletized, a 1 meter cube pallet, for instance. And yet again, you would move to another logistic device, say that this would be the pallet mover, which you see on the right side. So a single use case making use of 3 different autonomous vehicles. So these are vehicles that we are showing. And from a customer point of view, they are free to choose any type of vehicle that meets their requirement, not only from Ati, but also from our peers in the industry and so on. So the result is that the customer now has a fleet of vehicles from multiple vendors. And the challenge is to actually build a good end-to-end process that orchestrates and shows what is going on the shop floor. So that's the requirement. So let's talk about the landscape today. And before I do that, I'm going to introduce a few terms. We are going to be using this during the course of the talk. It's only important that we discuss what they are. So first, of course, is the autonomous mobile robot. All of you know this, features natural navigation. Then there is the previous generation AGV, automated guided vehicle, which needs a strip of a sort on the ground, could be magnetic, could be aluminum. The guidance happens through the strip. Then we have customers. These could be manufacturing facilities or warehousing facilities. where the customer is using one or more of these devices, could be both, I mean AMRs and AGVs, for automation in the facility. Now we define fleet as a collection of AMRs or AGVs or both of them for that matter. In the operating area of the facility, we typically define what are known as maps. This is AGVs and AMRs work under the aegis of a map. Inside the map, you have multiple routes defining the logistic operations required for that facility. So those are the routes. These are standard terminology, nothing different here. And of course, you have the fleet manager, which is a software component on the network side, which manages and orchestrates the activity. So with that as the background, let's look at how fleets are managed today. So in this case, I'm showing an example of non-overlapping vendor fleets. So you have three different vendor fleets here, each doing a specific task like the use case I introduced in the beginning. Each comes with its own fleet manager, shown color-coded here. And multi-vendor fleets are really a reality in modern manufacturing facilities. Even though they are a reality, they don't really solve some very fundamental problems that we keep seeing actually. So when these fleets cut across each other, where the routes intersect each other, we do not have a good traffic management solution, or they're going to be solutions developed by each one of these fleet managers, and they work in ways very specific to the fleet manager. And most importantly, the customer operator who is trying to put all of these together doesn't have a single digital dashboard or a viewing window from which he or she can actually do the orchestration. And what we mean by orchestration is, let's say there is a handoff between fleet one and fleet two. Fleet one is basically the raw material movement, let us say, and fleet two is taking the semi-finished goods to the QA area, and perhaps requires the activation of the pick and place arm that you see here. Now, if you want to coordinate this in a meaningful way, today what operators would have to do is to wait on the dashboard of fleet one to sort of see that the logistic movement is complete and that the part is really available for the second fleet to take over and so on. So that's what we mean by a single dashboard and orchestrating through a single dashboard, which is largely absent today. That's because each one of these are islands of computing and don't really share much of information across each other. Also, multi-vendor fleet management is significantly complex. And the people at this point who are trying to make this happen are customers who are not really subject matter experts. And it's actually outside their scope to sort of mediate with him or vendors to get this thing done. Last but not the least, the customer has paid for license for each of these fleet managers. So it actually is driving up the cost while achieving, subpar objectives, so to speak. So with this as the background or the problem statement, what does the VDA 5050 do at a top level in trying to solve this problem? So a VDA 5050 is a specification originated from the German automotive industry. It's currently in version 3 of the spec. It defines a fairly standard communication between the fleet management system and the MRs and AGVs that are elements of the fleet that it manages. So it's not only between fleet, a defined standard between activities of AMRs and their own fleet managers, but also across fleet managers and AMRs, so which results in interoperability of the fleet manager and AMRs from different manufacturers, thus enabling a single dashboard as well, because you would be visualizing all of this in a single system, because all the information is coming to a single system. So it, from a technical point of view, it frees up customers from interoperability issues. These problems are passed on to the AMR vendors and or fleet manager providers. So the customers are free to do, what they are supposed to do, which is the task of, manufacturing things and so on. From another perspective, it reduces cost and also number of components in the system. Now you don't have three fleet managers, you perhaps have a single one. And so the hosting of that fleet manager on compatible hardware and all that is off the table. So hence the cost is reduced. So for the rest of the discussion, when we say fleet manager, it's typically a VDA fleet manager or a compliant fleet manager, which embodies all the standards of VDA 5050 in interactions with AMRs and AGVs. So let's take a look at how this landscape of I mean, information not being shared across the islands of computing changes in a VDA world. So this is an introductory architecture as to how a VDA 50 fleet manager would work and perhaps control the same set of three fleets here. Uh, so what you see and what is most important value add from an operator perspective, this is the customer operator perspective, is that there is a single dashboard and it's managing a multi-vendor fleet. You not only see visualization of robots of one fleet, but actually you see all of them. And so if the operator wants to book a trip or do a logistic operation for one of the fleets, the interface that he uses is single, and it would be the same if you have to do a logistic operation for other fleets as well. So the learning curve from an operator perspective is significantly reduced. All the messages that go back and forth to make this dashboard view reality are basically JSON messages, to use a technical term. Those messages are defined in the standard. So for example, if you want to do a logistic movement, that would be an order message going from the master FM, which is the VDA 5050 compliant master FM, which goes through the bridge. This is a standard messaging component as part of the platform. Those messages go to individual bots in the fleet, and then they do the operation, which could be moving from A to B or from C to D, and so on. Now, since the operator is able to see the position and location of each of the bots, and this happens through visualization messages that come back from each of these bots onto the screen and shown in near real time. So the operator is now has a very familiar context with which to view them. He can actually see all of them. And it's actually so much easier for him to trigger an orchestration across the fleets as well. So often when these bots reach the endpoint, say for example, it's going from A to B, you would have to trigger some activities at the endpoint. So if you take the case of a pick and place on top of a bot, on reaching a endpoint station, you may further want to do some activity like pick a part of the table, put it on the ego table here, maybe on itself, or pick something on the on itself and put it on the table and so on. You can trigger the pick and place arm to come alive as an instant action after the bot has reached the destination point and so on. So these kinds of messages can be sent in a standards compliant way through the VDA 5050 definitions. I think we talked about the benefits fleet operator already. I mean, you can uniformly see all the bots in real time. So uniform control for all the elements of the fleet. Of course, a single dashboard, and last but not the least, a single fleet manager cost from a customer perspective. So this is a top-level introduction to the problem and how the VDA 5050 solves. So that, do you want to check if there are any questions?
Uh, Thanks for that. It was pretty detailed, Prasad. I think one of the questions that I can, put forward on behalf of a user here is in real time when I have multiple AMRs on a single fleet manager, can I view the status of the other AMRs or a different vendor's AMRs on the same fleet manager? That's one. I have a follow-on question. When it comes to the map, each AMR solution has its own map. So does that get integrated into our system, into the master fleet manager, or how does that work?
Those are excellent questions, Siddharth. Let me start with the first one. The first question was about would it be possible to see the visualization of each and every
Yes.
bot of different fleets? Now you could choose to, yes, the answer is yes. And the way you would want to visualize it also can be different. So for example, this is a map in which all the three bots are moving in a single map and perhaps they also intersect. Then it makes sense to show all of them together because they're actually doing things in conjunction with each other or cutting across lanes of each other. But if they're really disjoint fleets in the sense that the routes don't intersect, then this fleet manager dashboard has fleet specific views as well, just in case they do not intersect at all and they have nothing to do with each other. That's largely The former is the more common thing where you want to see the bots all on a single page. And yes, this is one of the fundamental capabilities of the Fleet Manager. Yes, you will be able to see in near real time where we are. Before I get to the maps, I wanted to show you a little bit about how this gets deployed, and we will get to the maps question because we talk about maps also in a little bit of detail in one of the subsequent slides. Now let's look at how this can get deployed. So this is the standard deployment architecture. You have Fleet Manager here, which is called the Master Fleet Manager, and it's VDA 5050 compliant, and it's managing two different fleets. So the protocol or the message definitions that go back and forth is VDA 5050 compliant. So here, both ends of the pipe are speaking the same language, so to speak. So we send VDA 5050 messages. On the other side, the bot is able to understand the VDA 50 message and do the desired activity, which is maybe perhaps do a logistic movement or stop or do a certain activity and so on. So this is directly controlling elements. So in this case, the messages are going from the fleet manager directly to elements of the bot fleet on both sides. Now, this is the more popular model, but having said that, there is also an alternate model where you could possibly keep an aggregator FM as an aggregator in between the master fleet manager and a vendor fleet, and we could still continue to have some private messaging going on between the aggregator FM, as I choose to call it, and the vendor fleet, whereas on the other side, the messages are going directly to the bot. This is also possible. It requires some implementation to get this right. But I think this is also possible, and in certain deployments where this is already prevalent, and you only need to develop VDA 5050 compliant messaging going on north of the aggregator FM, and south of the aggregator FM, the older private messaging continues to hold sway. So that's quickly possible deployment models with the VDA 5050. So once again, this is the standard model, but it's also possible to have an aggregator in between, which would continue to send private messaging between the vendor fleets, which they would then be wrapped up into VDA compliant messages and sent back to the master. We'll get to the mapping question directly. So the question was, is there an attempt to build a common map across the fleet? The answer is no. The reason being, each of these fleets have bots which have different sensors for map generation purposes. So the fleet one could have a multi-camera approach, for instance. Ati's fleet, of course, as Siddharth already pointed out, we have 3D LiDAR, and we have a fairly rich and dense map here. So the navigation under the edges of this map is typically left to the AMR itself, and it does so using the map that it generated using its own sensor elements. And so is the case with Fleet 2. Now, so that part doesn't change. However, when you want to visualize it in the context of plant coordinates or the entire shop floor, and this gray area is that I'm showing here, the gray background, the rectangle, let's say is the shop floor or manufacturing facility itself, in which these are three different areas where these two fleets actually intersect each other, meaning some of the routes could possibly be overlapping with each other or cutting across each other, whereas this one is completely off. Now it's possible to show this in a different window if the customer desires that way. These two however, have to be shown together for the simple reason that you really want to know, how they are doing at intersections and so on. So each one of these, as I said, would be operating under the edges of their own map. So there is a origin, so to speak, of each of these maps, which is shown as 00 here in a very fleet specific way. But we also know that the 00 of fleet 1, for instance, is relative to plant coordinates. It's at a certain xt and a yt with a transformation applied. Now, I have vastly simplified this by saying, only the xt and yt. There could also be a rotational component, in which case you apply the transformation. And then the visualization messages that are coming to the master fleet manager from these fleets are relative to their own coordinate system, which can then be transformed and shown in plant coordinate system. So this is how a common visualization with references in the plant, which are very familiar to the operator. So you present it in a context that is familiar to the operator, which is in plant coordinates. And then you have a good visualization of what's going on in each of the fleets in a way that operators are comfortable with. I hope I answered the map question.
Yeah, Prasad, I think that was brilliantly put, because at the end of the day, as a user, the whole idea of what VDA 5050 is going to enable for the user is to break down these silos, and the view of the material movement can happen exactly like you've mentioned in terms of plant coordinate. So thank you for answering that question. I think that's a great insight.
Right. So there are a couple of more challenges. I mean, there are many, but I would like to highlight only a few here. So this is one. How are maps done? Is there an attempt to build a common map? The answer is no. And this is only a visualization is done. Let's talk a little bit about, let's do the intersection management a little bit later. So let's talk about the second challenge that you would frequently run into. So when you work with AMRs and AGVs, they're of course differently abled. From a differently abled perspective, let's just say we have to do a route from A to B, for instance. This is also a bit technical, but I'll break it down. So the master fleet manager could ask the AMR to go from A to B. Now, AMRs typically can do the planning. And what I mean by planning is the sequence of sub steps that you have to do to reach the desired goal, which is B. That would mean going through points P1, P2, and P3. It's not just three, there could be several hundreds. Depends on the kind of path planning that is done. What I meant to say is this computation of what are the paths, subset paths in between A and B is done typically on board the AMR. Now, when it comes to the AGV, that may expect that this computation, it is not it doesn't have the compute resources to be able to do this kind of path planning on board, and instead relies on the master fleet manager to tell it what to do. So the kind of packet that you would send for an AMR would be a broad directive which says go from A to B, and that's enough, and the AMR would execute it. Whereas for the AGV, you would then have to do the path planning exercise and bury all these things as part of a trajectory segment in the same order JSON, which is optional and absent in the case of AMR, would then be present in the case of AGV. So what we wanted to highlight is that as master fleet manager developers, we have to be cognizant, and this was the lesson learned trying to build our own product, be cognizant of differently abled AMRs and AGVs fleets that we are managing. And this is usually done by discussing with the vendors fleets that we are managing, what kind of detail they want. We also talked about endpoint activities. What are the last mile activities that you should do after reaching the endpoint can also be sent as part of the VDA JSON, the order JSON that is. So a little bit of a paper and pencil exercise would be very useful, and both parties arrive at a consensus as exactly what they expect the master FM to do. So this is one of the challenges. I chose to highlight this because when you integrate with different vendors, each one would have a different level of expectation from the master FM. So the third question we get often asked is how do you do intersection management? The spec doesn't specify how to do intersection management in any great level of detail. But one possible way to do is, let us say we have map metadata, enough metadata of two fleets here. One is a fleet that has a route going from A to B, and this is the other fleet that has a route going from C to D, and of course they intersect at I. The metadata already tells us in these routes you have an intersection. The metadata comes from the mapping data, which comes from the individual fleets. So once we know that there is an intersection like this, so in the customer operator that is, has asked for a logistic movement from A to B, for instance, you would then break it up into subsegments. For example, knowing fully well that there is an intersection, you would then ask this bot to only go up to I. The second part of the route, which is going from I to B, is unknown to this bot till such time the fleet manager, which is the master fleet manager, decides it's safe for it to do so. And how does that decide? Now, for example, this bot is also going from C to D, and it is only told go up to I, for instance, and both of them have reached here. Whichever came first, let's say the blue vehicle came first here. The master fleet manager would then unravel the second segment for this vehicle. So it would then do the segment A to D. And since we get constant location updates from the vehicle, the master fleet manager is in a unique position to figure out that this is safely crossed the intersection and then unravels the segment I to B for the spot. So this is one of the ways of doing. Ati also has REST APIs that we expose, and customers are free to integrate against the REST API. So what this bot would then do is it would request for permissions to cross the intersection. This bot would do the same. One of them would win depending on who sent the request first, and safe passage is ensured for both. So this way we can avoid potential deadlocks, and yeah, there is a way to do it in a VDA generic way, but you can also do it if the bots are aware that they are approaching an intersection, they could just simply call the REST API and solve the intersection issue. So these are some of the challenges that we as implementers of the Master FM faced and solved in a certain way. We wanted to highlight that. So that would be a good time to check if there are questions.
Yes, so I think one of the questions from Suranshu has essentially talking about in case there is a situation where on on ground where there is an integration that has to be done between one Ati fleet manager and a different AMR OEM. In that case, what's a typical timeline to have this integration go live from a standpoint of, let's say, an initial agreement of operating together is reached with Ati fleet manager being the primary fleet manager. And we have a follow-on question that is pretty much related to that. This is from Miguel, where he's asking, and I think it's partly answered, where he asked us about what would it take for an integration to be done in terms of whether each AMR vendor has to, do an integration at a bot level on each bot, or is this an integration that happens between the two fleet managers?
Right. So this slide definitely answers part of the question. So here you have a situation where the bots are directly the target of messages from the master in this fleet, whereas here it goes through an aggregator. The aggregator does translations back and forth. Admittedly, this is an extra component in the network, perhaps hosted on a certain hardware and has its own software. It's probably not going to induce any latencies, but this is a component from an engineering point of view that has to be managed and so on. So that is the only difference that I see. Both of these models can be deployed to solve a problem. It largely depends on the context that I answered Miguel's question. Now,
Yes.
the previous question about how long and timelines, I'd like to
Yes.
answer that in the context of the big picture. It's not only about trying to get both ends of the pipe right. Now, if you look at how, I'm going to fast forward this to a slide that I want to talk about from a low code integration perspective as well. So now, very rarely is the picture as simple as, sorry, I'm going across slides. This is very rarely as simple as this slide or this slide. So it talks directly and so on. So all of these fleets sort of exist in an ecosystem. And what does the ecosystem look like in today's manufacturing facilities? So yes, we have at these components. I'll talk at length about the deployment manager shortly. But the master FM needs to be integrated with the manufacturing automation system. These are customer backends which are doing largely the production planning and control for the shift or for the day and so on. These are heavily I4.0 compliant, and they are now doing planning activities for not only one fleet, but maybe multiple fleets. Now, this has to be able to integrate and absorb multiple recipes for multiple fleets. So it's not as simple as just getting the master to talk VDA 50/50. And then you also have interesting requirements from customers, which is so we would like to know at any given point in time who among our many operators who are running the activities on the shop floor did a specific route from A to B at maybe 3 p.m. in the afternoon. So from an audit perspective, it is important to tag the activities done by each and every operator in the customer facility And most importantly, how do you find out who's who? Is basically there is an integration already done with the customer's single sign-on server. So let's say Prasad Atati logged in, and when I log in through the dashboard here, which is what Fleet Manager would first show me, I would be giving my Ati credentials, which would then get validated against the SSO server. So this ecosystem has to exist before nicely integrated before you can do anything. And the most important part of that question is now that we know we are going to integrate in this facility and that there are maps and possibly integrate intersecting or non-intersecting and so on, you would then want to provide the individual vendor fleet operators a deployment manager or a low code integration dashboard. And what I mean by that is they can upload map metadata. So they'll have a dashboard in which they will now give the right time, right kind of terminology and nomenclature for their routes. What are the stations where there are activities? Where would you like the bot to stop? Are there intersections? So typically route metadata, intersection metadata, and more map data that would need to be captured through the interfaces that we give to individual fleet vendors. That needs to be pushed into the master to get the larger picture of how it should orchestrate the use case. So the success of any deployment like this would be critically dependent on how efficient the low code integration and what kind of simple interface have we given to each of these vendors so that they can do their job quickly and test it. Because as we know, testing the use case under the customer facilities in a way that it matches their specific requirements to a T requires a lot of iteration. I mean, a lot of iteration going on here, a lot of iteration going on here. There could be iterations here too. They have very dynamic recipe planning. For instance, let's say they change the product being developed across a shift. So first 4 hours they do something, the other 4 hours they may be doing something else. When such a thing comes to you, how do you make sure that the fleets are orchestrated properly to achieve the objective? So it's never a simple picture of being VDA compliant. What you need is a master fleet manager that has ability and has a proven track record of having integrated with all of these customers and with all of these customer backends. And more importantly, data security and data protection issues come to the fore. We are now dealing with data and analytics of multiple fleets. So adherence to data protection standards in each of those geographies would be very important. So then also exporting analytics data to vendor-specific fleets in a very secure manner, giving confidence both to the customer as well as the vendor fleets is of paramount importance, and we won't succeed without doing justice to each of these blocks. This is just a small picture. I'm pretty sure there are more complexities, but I wanted to highlight it's not just about getting the pipe right, but also the plumbing to the rest of the components in the big picture. That was a long answer to Subramshu's question, but I hope I was able to do justice to it.
No, absolutely. I think you've answered maybe a couple of other questions too that I was going to post in terms of
Please go ahead.
how a
We can.
deployment manager would, facilitate an integration. And I think a lot of that has been covered in terms of, how we can create a low code environment to do something like this. Let's talk about a real world scenario that I thought I should put forward in this specific case. Now, for
Okay.
example, you mentioned that obviously very I4.0 advanced systems that are in place in factories are directly integrated using REST APIs with the master FM here. So
Mm-hmm.
my question here is, can logic, production related logic from the MES be translated to the FM and the FM can act on that logic? Let me put that across as an example. You're at a junction where there is a Sherpa tug and there is a different AMR that are to be to are reaching at an intersection, and both of them are carrying material for the same line. And the sequence in which the material is to reach the line is Sherpa 1, uh, AMR 2. I mean, I'm talking in terms of the product that the AMRs are carrying. In case AMR 2 reaches the junction before Sherpa reaches the junction, the right of way is going to be assigned purely on the basis of when an AMR reaches the junction, or can that sequence in which these two AMRs have to align at the single path after the junction and reach the endpoint, can that sequence be adhered to by the fleet manager?
Right. If they are doing, and let me repeat the question just to make sure I've understood. So the question was, I4.0 directives can be fairly complex, and they would perhaps require sequencing elements of each one of these in a particular order. And in that context, if uh, a bot from this fleet reached a certain location, and so is a bot from the other fleet at the same location, and if I were to use normal logic of whoever reached first would go first, and whereas the customer's expectation would be that if they are both doing the trip for the same use case, I would prefer this to go first and this to go second. So yes, we can. It's a very involved, deep dive question, but yes, it is possible. For example, we can assign priorities differently. So at the intersection, instead of looking at the arrival time at the intersection, we could perhaps give priority or a weightage on a higher priority basis to this, and so this would get the right of way, whereas the second bot would wait. Yeah, but this can be solved from a traffic management perspective also by assigning different weights to each of these fleets, so something else gets a priority in the order desired, that is. But yes, it could also be, we can also see this from a perspective of Industry 4.0 and how to sequence material to a station. Yeah, it can be controlled in exactly the way that you just described. I hope I answered your question. I'm not very sure
Uh,
I got all of it.
Very, very interesting because this truly enables seamless sharing of information at each AMR level too. I mean, thank you, Guru. I mean, that clearly answers my question.
Right? Are there other questions?
We can
Going
now,
on this slide, I just want to make sure all the points are covered and so on.
thank you. We can move on.
All right, we'll move on. So I'm just going to summarize and close. So the benefits, a quick view, top level view of what are the benefits that we see with the VDA 5050 Fleet Manager. So from an industry perspective and customers and operator perspective, it enables seamless operations across multiple fleets, and you can independently scale across each of them. Of course, you'll have to scale the master fleet manager also accordingly, but that is a known issue, how to scale software systems and so on. From a customer perspective, as we said, there is no lock-in. I would like to reiterate that point. Now, let's just say a fleet one got in there first, and so fleet manager one is something that has been with the customer for a very long time. The customer is not now compelled to buy bots from that same vendor. There is no lock-in, so to speak. And since interoperability is now under the aegis of this standard, and vendors are supposed to comply with that, the interoperability issue is effectively removed from a customer responsibility. And as we already mentioned, the number of components in the system reduces, management effort is less, and of course, cost is reduced. So that's from a customer perspective. From a vendor perspective, it's actually quite interesting. Much as you would think that if I don't have my fleet manager, I lose the place. Not really. Aligning with this specs gives you a level playing field. You could mix and match with any fleet manager as long as your bot meets the expectations of the customer. So yes, this is an important perspective. I think level playing field is what most of us desire. So that step, this spec is a spec. Sorry, this spec is a step in the right direction. And it's also evolving as we speak. As I said, it's in V3 now. And we at Athi proud to have implemented it. And yes, that is a quick overview of VDA 5050, the models that are in place, and also Athi's implementation. Any questions?
we have a question from one of the attendees here. How do we manage last mile maneuvers? Is that a question which is complete, if I may ask, Guru, or do you want
Yes,
some?
it is a good question. I will go back to this little thing that I had put. What are the messages that you can send? So let us say there is a logistic movement requirement from A to B, But after having got to B, you want to do some specific activities. So, for example, like I said, you may want to trigger the pick and place operations and so on. Those are achieved by what are called as instant action, typically at endpoints. Another example is the charging directive. Now, there is what is known as a state message, apart from location visualization, which basically tells the state of the AMR. So you would be able to find out the state of charge of batteries of each one of those. And it would help the customer enforce an objective like this. When the battery SOC is below 10%, don't assign any more trips and instead send the bot to the charging location. And in some cases, the AMR will also require last mile movement to dock to the charging station. That is an instant action at the last mile. And also a specific directive needs to be sent for some AMRs to actually begin the charging. So those are some examples of last mile things that you may have to do. Charging is a very good example of that. And I hope I did justice to the question.
Yeah, I could in my mind understand the answer to that question. Thanks for that. Thanks for that, Guru. I hope it brought the relevant answer to the person who asked this question.
Right. So this picture is most important. It's not just about VDA compliance, how to get the big picture right, and with the compliance also in mind.
And so one of the things that I wanted to also bring up here in terms of we speak about the architecture and how the system works on presentation here, but is this something we've been able to deploy? Is this a reality in any one of our deployments?
Yes, the master FM, the Fleet Manager Master VDA FM is in beta testing with a vendor fleet with a large automotive OEM. It's going on. I think it's a
Interesting.
German OEM, but that's about all I can say at this point.
Interesting. And in that configuration, are we directly speaking with the other AMRs, or are we talking to them through their fleet manager?
Actually, the former, we are talking directly to the elements of the fleet from the master fleet manager.
From a user's perspective, just as a user, do you think it would be more complicated to integrate directly with the other AMRs, or is it more feasible and uh, easier to or faster to deploy if I were to have a configuration where the master fleet manager speaks to the other AMRs through their fleet manager from a complexity standpoint?
Right. So if we encounter this picture and there's a lot of thing going on between a vendor fleet and its aggregator fleet. They're all working together with the T. There's a whole bunch of private stuff going on. It may be the case that you may not be able to fit all of this private messaging without knowing exactly what they are at this point. If there's a lot that's going on and it can't be fit into the ages of the 50/50, VDA 50/50, then maybe what would be expedient is to continue this, whereas the north interfaces of the aggregator could do VDA 50/50 and give a quick turnaround for integration. But by and large, those messages are anyway under fleet operations and so on. But it depends really on how vendor has implemented and what is going on in this interface and whether those can be transformed into equivalent VDA 50/50 messages is the right way to look at it. The upfront analysis will answer the question. I would think if you already have a pipe from here to here, and this is already an established fleet going on for a while, it may be simpler to put another pipe and talk this language and then do the translations on the other side. Yes, it introduces an additional component, but I know you just this may be more simpler in some cases, but we have to look at it on a case by case basis.
So we're close to the end of our webinar here, and I just want to put one final question out there, which is
Please.
part of it could be looked at as a follow-on question. So from this explanation, this slide, can I say that the fleet manager of the partner, the aggregator fleet manager, the one that is marked in blue, only that FM can be VDA 50/50 compliant. The bots individually need not be VDA 50/50 compliant. And we can still achieve integration between both the fleet managers, and ATI FM can be the master fleet manager.
Fair enough. It's possible to do so. Yes, the spec lists this as a possibility. And yes, we can develop interface only these interface, whereas as I said, this is already going on. They know how to work with each other very well. Yes, this is unique and it's possible.
Great. We don't have any more questions, Guru, right now. Thank you so much for your time to make this discussion on Fleet Manager a reality. We thank all our participants here too for joining us. And please feel free to reach out to us in response to our communications to you regarding this event. On any further questions that you may have, we will try and make this available on YouTube for later reference. And once again, thank you for joining.
Yeah, thank you all very much for joining. Those questions were important and thought-provoking as well. I hope we were able to do justice to those questions. And yes, please reach out if you have more questions.
Thank you so much, team. Have a good day ahead. Bye-bye.
Thank you all. Have a good day. Are we still on?